All right, so welcome to those of us who are joining on YouTube. So this is our first Zoom session, Precalculus in spring 2020. So what we're going to start here with a little bit of review, stuff that we were doing before we went remote. And we were thinking about sort of trigonometry, and we had two functions, right? So we had two functions that we were considering. One was the sine function, and the other one was the cosine function. And so we use this notation, sine x and cosine x. So does this look good for everybody? We can see this pretty well?
Mm-hmm.
Okay.
Yeah.
So a couple of facts, right? So when we were thinking about these functions, we kept on thinking about them as part of the unit circle. So we've studied unit circle trigonometry so far. And what we have is we have a point that's on the unit circle, and then sine is going to give us the y coordinate of that point, and cosine is going to give us the x coordinate of that point. Okay, so if we pick a point on the unit circle, it always has the form cosine x comma sine x. Okay, and so so when we say x here, I'm actually going to not use x. I'm going to use t, because our angle that we were thinking about, right? So t is this angle right here, right? So sometimes you use theta, sometimes you use t, but the angle that is traversed, right? So the measure of this arc length right here, or the angle that gives us sine and cosine. Okay, so we input an angle, and then we get an output that is some coordinate on the unit circle. And so what we did is we had a chart that looked something like this, right? So we had sine x and we had cosine x, and then we had our angle here that was x, right? So we had a nice chart. And our angles were 0, pi over 6, pi over 4, pi over 3, and pi over 2, right? So these were what we called our reference angles, or our learning angles. And what they do is they correspond in degree measures. So this is 0 degrees, this is 30 degrees, this is 45 degrees, 60 degrees, and then all the way out to 90 degrees. And so what we have up here, these are our radian measures, and these are our degree measures. Okay, so we have radians and degrees, and we can fill out this chart. We have this method where we sort of count 0, 1, 2, 3, 4. And so when we think about this, right, so we're always going to be thinking about something of the form square root of something divided by 2. Okay, so the first time when I start here, I'm going to have 0. So the square root of 0 over 2 is 0. Square root of 1 over 2 is a half. Then we have square root of 2 over 2, square root of 3 over 2, and then 1. Okay, and so then when we go backwards, 0, 1 half, square root of 2 over 2, square root of 3 over 2, and then 1. All right, so how does this look for everybody? Is it a little bit small, or is it okay?
Yeah, it's fine.
It's fine? Okay. All right, so far so good. We feel pretty good about this?
Yeah,
you remember doing this stuff? So we'll wait, see what people say in the chat.
Yeah. Didn't we do this before break, right?
Yeah, we did all this before break. I just kind of want to give us a quick reminder. So if you have like your notes at home, this would be good to sort of bring out as a reference. So this chart is going to be really helpful. For us. Okay. All right. So what I want to do is I'm going to pin this. If we can all see it, I mean, I think it's going to get pretty small, so I might have to recreate it here, but that's okay. So what we're going to do now is we're actually going to build some other functions based off of sine and cosine. So everything that we're going to do from here is going to be we're always going to go back to thinking about, hey, what is sine, what is cosine, and how do I combine those two things to create my new function. Okay. So let's come back over here, and we are gonna zoom into our Blackboard. Okay, so what you should be able to see is this, that document cam should be fixed up there. So again, what we showed earlier is if you go into that active speaker view, you can make that board a little bit bigger, and then it's still there. It's pinned just as a reference for us that we can still see off to the side, right? So if we ever want to go back and think, we have that there displayed at all times. All right, so what we're going to be thinking about, there's going to be 4 new functions that we bring into play. The first one is called tangent, and we use this notation tan x. And then the other one is cotangent, so we use this COT of x. And then we have a function secant, and then we have a function cosecant of x. Okay. And if you've seen this before, what we're going to do is we're going to use sine and cosine to represent all of these functions. Okay, so tangent is defined to be sine divided by cosine. Okay, so anytime that I have a tangent value, anytime I'm thinking about this function tangent, what I'm going to do is I'm always going to go back and I'm going to be thinking about, hey, what is sine and what is cosine? Okay. And then if we think about cotangent, we're going to do the opposite here. We're going to do cosine all divided by sine. Okay. So I'll write out all of these. This one is 1 over cosine, and this one is 1 over sine. Okay, so these are our 4 new functions. And if you're thinking about this, so if you don't want to reference the video, right? So if you don't have these written down, keep in mind that if we go back to our Plato page, we have this in our notes. Okay, so this is back to our Plato page. If we click over here on activities on the sidebar, then we have all of our notes, right? So this is all of my activities that I posted that I've created for this class, so guided activities for pre-calculus. The PDF is pretty nice because these are hyperlinked. So what we're working through right now is this other trigonometric functions. Okay, so in your notes, right, you have this available to you as well. So all of this is here, right? Tangent, secant, cotangent, and cosecant. So what I want to do to start is I want to think about this example right here, right? So let's think about tangent of 5 pi over 6, and we'll see if we can figure out, say, how to evaluate that. Okay, so we're gonna jump back to our Blackboard here, and let's see if we can do some fancy stuff. And so here's our definitions, and our goal is going to be to think about this function here, right? What is tangent of 5 pi over 6? So what I want everybody to do is keep in mind that when we think about tangent, we're thinking about this over here, right? So we're thinking, hey, tangent, whenever I plug in this, I'm going to be looking at our sine and cosine values. And so what we'll do is we'll do something like this. Hey, we have sine of 5 pi over 6, and then we're going to divide this by cosine of 5 pi over 6. Okay, so what I've done is I've taken this sort of complex problem over here, which is tangent, that we're not exactly sure how to evaluate, and I've broken it up into 2 separate problems, right? A problem where I have to think about what is sine of 5 pi over 6 and what is cosine of 5 pi over 6. So I want to think about this for a second, and let's see if we can remember how to evaluate this. So how do I evaluate sine of 5 pi over 6 and cosine of 5 pi over 6? Any ideas out there?
I have no clue.
All right, so I'm also looking at the chat here. If people want to have it in the chat. So if we think about our chart, if I go over here to my chart, right, pi over 6, 5 pi over 6, 5 pi over 6 isn't in this chart, but I can use that to help me out. So do we remember looking at reference angles, right? So we think about reference angles and we would say, hey, we know we have this has the same value. Okay, so sine of 5 pi over 6, it's going to be the same number as what we referenced in the first quadrant. So 5 pi over 6 is going to have the same values as pi over 6. Okay, but we have to think about, hey, what quadrant is this thing in? So 5 pi over 6, if I recall, it's in radians, and in order to figure out what quadrant it is in, we would want to try and quickly convert to degrees. So anybody remember how to do that? How do I take this 5 pi over 6 and convert it to degrees?
Isn't 180 over pi?
Yeah, right. So I'm going to take this, I'm going to multiply by 180 over pi. So let's do this off to the side. We're going to take 5 pi over 6 times 180 over pi. Right, so my pi's are going to cancel out. 180 over 6, that's 30. And 30 times 5, so this is going to end up being 150 degrees. Right, so if you wanted to, you could plug that into Desmos. It should tell you that's 150. So what quadrant is that in?
Second.
Quadrant 2, yeah, right? So this is quadrant 2. Okay, so what that tells me is in quadrant 2, my cosine values are going to be negative, right? And my sine values are going to be positive. And what I can do is just go over to my chart and look these things up. So I know that pi over 6 is going to have the same reference angle as 5 pi over 6. Okay, so what we get here, this value is, right, so sine of 5 pi over 6 is going to be the same value as pi over 6, which is a half. And in quadrant 2, I know it's going to be a positive number, so we'll leave it like that. And then cosine is going to have the same number, square root of 3 over 2, but it's quadrant 2, so it's negative. Okay, so then we have something that looks like this. Okay. Now, when I look at this down here, fraction inside of a fraction, right? Pretty not great for a lot of us. So when you see this, my tip for you is, what I want you to do is think about, instead of dividing by this denominator right here, what I want to do is I want to multiply by the reciprocal. So really this is 1/2 times negative 2 over the square root of 3. Okay. And then dividing is the same as multiplying by the reciprocal. So these twos are going to canceling out. And then I get negative 1 over the square root of 3. Okay. So when I think about this, this is our general process. If you want to find the exact value for some of these things, you would go through this sort of process here. Everything comes back to breaking it down into sines and cosines. Okay.
Mm-hmm.
All right, so I want to pause here for a second and check in with you all. See, are there any steps here that were good, bad, otherwise?
No, it's not that bad. They're just like just simplifying the equation.
Okay, so if we flip back here to our notes, does everybody have our notes up? So again, we have some technical difficulties here. We can do them back over here. So do we want to try out another example?
Yeah.
Mm-hmm.
Yeah.
Sure.
Okay, so let's try another example. What I'm going to do is get a new screen up here. Okay, and so let's try to find what is cosecant of let's say pi over 3. We'll try this one. And then let's try secant of 2 pi over 3. Okay, so just sort of making things up right now. Let's try these out. I'm going to give you a minute to think about these, right? So think about them on your own, see what we can do, and then we'll come back together, right? So if you totally have no idea what to do, just send me a chat message or something. Seems like people are good so far. All right, so I'm sort of filling us in some details here. So how are we doing so far? Do we think about this first one? Everybody check in with cosecant yet?
I thought it was supposed to be sine over cosine for the first one.
So that's only for our tangent function, right? So if I go back over here, so if we zoom in, we can sort of check this out again. So when we think about this, you have sine over cosine only with tangent. Right? So this new tangent function will be sine over cosine, but we have these 4 different definitions. So cosecant has this definition 1 over sine, and secant has this definition 1 over cosine.
All right, cool.
Okay, so depending on the function you're using, they're going to have one of these 4 definitions. Okay, so we'll bring this back and we can jump up to the other screen. Are there questions so far?
No, I got it.
I got it. All right. So what about this one? So we plug it in, right? So we have 1 over sine of pi over 3. We have this. And now what do we do? Right? We have our table over here, right? So we can go over here and look up, hey, sine of pi over 3, I know what that is. That's in my table. So this is 1 over, and then this is the square root of 3 over 2. Okay, so I got that from right here, if you can see in the doc cam. It's square root of 3 over 2. And again, dividing, same as multiplying by the reciprocal. So this ends up being 2 over the square root of 3. Right? So if we wanted the exact value of cosecant of pi over 3, we could get this 2 divided by square root of 3. And then if you wanted a decimal approximation for this thing, absolutely we could use Desmos. But sometimes we want exact values, then we can use. We'll go through this process. So what about this one? Same thing, a little bit different. What do y'all think?
Well, the reference angle is pi over 3, right?
Yep. That reference angle for this one would be pi over 3.
But that's in the second quadrant.
Correct.
So it's going to be negative because it's cosine.
Yep. Quadrant 2. So cosine is negative. Yep. And you're exactly right. The reference angle is pi over 3. Okay, so what we do is you have 1 over, now cosine, the reference angle, this right here tells us the value, so it's going to be the same cosine value as pi over 3, right? That gives us the number, but then we use the quadrant to tell us that it's negative. Okay, so when this all shakes out, 1 divided by negative 1/2 is the same as 1 times negative 2 over 1, right? Dividing is the same as multiplying by the reciprocal. And so this ends up being negative 2. And so we should see that secant of 2 pi over 3 is negative 2. All right, so see how we always go back? We're always coming back to, you know, this idea. What quadrant is the angle in, and what's our reference angle?
So what if we do if we get a problem like we want to find out like pi over 5 or whatever, something that's not in our table?
So the short answer to that is we would use the calculator. We would approximate it. So the reason that we use these ones, I call them learning angles, because it just helps us when we think about these special angles right here. It helps us understand the definitions of these functions, right? So really, in practice, if you want to find this value, you're just going to plug this into a calculator. Right, so that's the reality of this. But what this process does is this is like working out, right? This is like riding a bike or running on the treadmill or something. So it helps us think about, you know, what are our angle measures, and it helps us think about the definitions, right? What do these functions mean, and sort of when would we use them, right? So what we're going to see later on in the semester is we're going to see triangles that these correspond to different triangles. So when you want to do measurements, like in geometry, you want to measure different side lengths of triangles. These things really come in handy for that. Right? And so right now we're building up the definitions, understanding what they do, and then a little bit later on we're going to come back to trigonometry, and we're going to apply them to geometry and the geometry of triangles in particular.
Okay.
Does that make a little bit more sense?
Yeah. Mm-hmm.
Yeah, so I mean, that is the real reality, right? So if our end goal is to get this number, just use the calculator. But this process that we're walking through, think of it more like, you know, working out or something. You know, it helps us make our brains a little bit stronger. Okay. Okay, so a problem that you might see, right? So on our web work homework, they give us problems that look something like this. Okay, what is tangent of 990 degrees? I think something like this. Does anybody have any ideas how we might tackle this one?
You don't want us to use a graph calculator, right?
Well, yeah, if you wanted the end result, like if all you wanted, your only goal was to get the answer, then yeah, absolutely. Yeah, so Jordan, you could convert from degrees. We could actually leave this one in degrees too. I mean, so either way, it doesn't matter. I think if we want to think about quadrants, it might be easier to leave it in degrees. But you could, right? So if you feel more comfortable using radians, you could absolutely turn it back into radians. So any other ideas? So here's a question before we even think about this. If I just asked you 990 degrees, so here's a unit circle. Remember, we always start over here. If I go 990 degrees, where am I?
360. Wouldn't you be in the second quadrant or the first?
So we're not going to be in quadrant 2 now. So, but Gabe, I like what you said. You said 360, right? So you said if I go all the way around one time, that's 360. I didn't reach 990 yet. So I got to go around again, right?
Yeah.
Go all the way around again the second time. And now where am I? 360 plus 360 is 720.
720.
Yeah. So now can I go around again?
I think, wait, isn't it to like the third quadrant?
It's closer. Yeah, you're closer.
Than the fourth one, honestly.
Right, so how many more degrees do we have from 720 to 990?
270.
Yeah.
Yeah, we need 270 more, right?
So it's
Where are we?
right? It's on the y-axis, the third quadrant.
Yeah, it's on the y-axis, right? So let's go ahead and I'm gonna erase some of this. I'm gonna clean it up. Okay, so right, so we don't need this. We don't need this. Can you have my daughter in the background?
Yeah.
Yeah. So yeah, we're gonna get that a lot, but same goes for all you, right? So she's gonna be in the background in a lot of the videos, but if you have people that need to come in, absolutely bring them with you. So if you need to take care of siblings or your friends or your family members or your own kids, bring them with you.
Right.
They're all welcome. Okay. So 270 more. So if I'm here after 720, I keep going. This would be 90 more. This would be 180 more, and then 270 would put us right here, right? So this would be 990 degrees. Okay. So what happens, right? So we would look at this thing, we would say, tangent, this is really sine of 990, and then divided by cosine of 990. And so these aren't in our table, right? But if I look at this point, right? So if I go to my point on the unit circle, can we think about this right here? What are the x and y coordinates of that point?
First one, the one on the x-axis.
Yeah, so this red point right here, what are my x and y coordinates?
0, 990.
Negative
Or
1.
0, negative 1, and
It's the unit circle. Right,
and
so
next
this is the unit circle. So our coordinates are 0, negative 1. So cosine is our x coordinate, right? And sine is our y coordinate. So this is negative 1 divided by 0. If you get something like this, tangent of 990, negative 1 divided by 0. And can we ever divide anything by 0?
No.
No, right? So this is undefined. So sometimes what you might run into is some of these new functions, tangent, cotangent, secant, and cosecant. Sometimes they are undefined, right? Sometimes they don't exist. So you're not always going to get a value for all these things.
All right.
Okay. So I guess the next question that I have is, well, can you sort of tell me when this would happen, right? So if I think about this process, right, so I have this special value over here that my tangent value was undefined at. So we might be able to sort of figure out when tangent is going to be undefined. Okay, so here's a question. When is tangent undefined? Okay. And if we go back one slide, now, specifically what happened to make this thing get undefined?
It's in like the negative axis.
So it's negative, yeah. So like, what about this thing? So if I come down here and I think about these two, right? So if I think about this part, is the -1 making it undefined, or is the 0 making it undefined?
0.
Yeah.
0.
Yeah. So Jordan, right? It gets divided by 0. So you're dividing this thing by 0. So anytime that I'm going to divide by 0, I'm going to be undefined. Okay. So this is our one observation, right? When we divide by 0. Okay, so when does that happen? So tangent is, we said, was sine over cosine. And then going back here, notice that, hey, the division by 0, well, the division by 0 happened here, right? This thing right here, this is what caused us to divide by 0 when cosine was 0, right? So we'll come back over here. And now the question is, well, when is cosine 0? Any ideas?
Whenever a point's on the y-axis.
So whenever a point is on the y-axis. Yeah, so you're thinking about unit circle again, Nick?
Yeah.
Right, so here and here. Right?
Yeah.
So do you know what those degree measures are?
It's 90 and 270, right?
Yep, and if we kept going, right, it would be 90 and 270. But then this would also be
450.
right, 450. And if we kept going, it would be 630. Right, so how do we get these things? Plus 360, right? So anytime I add 360 or subtract 360, I'm going to get the same thing. Okay. If we think about this in radians, well, these radian measures are pi over 2, right? So up here is pi over 2, right? So the top, this is pi over 2, and then we'd also have the bottom would be 3 pi over 2.
Oh, shit.
Okay. Now, if I count around, right? So if you remember what we did before in class, we said if this is 0, this step was 1 pi over 2, 2 pi over 2, 3 pi over 2 is here, 4 pi over 2. When we get back up to the top, we're going to get 5 pi over 2. Okay. And then we go here, 6 pi over 2, and down the bottom is going to be 7 pi over 2. Right. So if we put these in here, right, we're also going to have 5 pi over 2. We're going to have 7 pi over 2. Does anybody see any patterns yet? 8 pi over 2. This is going to be 9 pi over 2, 10, 11. Right, so we get 9 pi over 2, 11 pi over 2. Anybody notice any patterns?
It's all the odd numbered pi's divided by 2.
Yeah, always odd, right? Odd number times pi over 2. So anytime we have an odd number multiplied by pi over 2, that's when tangent is going to be undefined when you're thinking about radians. Okay, so what I'm going to do here is I'm going to jump out of this. I'm going to go into I'm going to just jump into my browser. I'm going to go to Desmos. Okay. And let's check this out. Okay, so we're thinking about Desmos, and I want to look at this function tan x. Okay, so if I look at the graph of it, it's going to look something like this. And notice that we get sort of these vertical lines right here. Yeah, so like this is a point where my graph is undefined. And so what I want to type in here, I'm going to type in x equals pi over 2, okay? And I'm going to change my style here. So notice what's happening here, right? This acts like a vertical asymptote. So as we get close to this line, we're pretty good. You all hear my daughter there?
Yeah.
Yeah, she's at home with us too.
Mm-hmm.
Okay. So, right, so we can see that, right, we have our tangent function that hits these different values, right, so these vertical asymptotes. But, okay, so far so good.
Yeah.
We're connecting these representations. And so what we'll see, we'll do some stuff, right? So it's important to just identify what the graphs of these things look like. So I'm going to leave it to you all to sort of play around with the other ones and see what they are. But this process is pretty much the same for the others, right? So whenever the denominator is going to be 0, you're going to get these things that are undefined, okay? All right, so if we just try one more, right? So if we try, say, cosecant of x. So cosecant, we said, was the same as 1 over sine. So this thing's going to be 0 whenever sine is 0, which will be the even multiples of pi over 2, right? So if I do something like 2 times pi over 2, right? So I'm going to do, so to do x equals, okay? And again, I'll just make it a dashed line. You can see that, right, at an even multiple of pi over 2, we're going to get this vertical asymptote. And that will just keep happening, right? 0, 2, 4, 6. Those are all these different spots, right? So this would be 0, 2, 3, and we would have this general shape going on. Okay. All right. Questions so far? Comments, concerns?
I just have a question. When's the art project due for like the portrait?
2 weeks, and then I actually wanted to take the last couple of minutes to talk about that.
Oh, okay.
So yeah, 2 weeks. I think I put a temporary due date on 2 weeks, so at the end of next week we would do that. But anybody else questions about the trigonometry stuff? So a lot of us are being pretty quiet, but you can also remember you can type into the chat as well. So you can chat to each other or you can chat to everybody, right? So in the chat, you have a little blue box. You can chat to anybody individually or you can chat to everybody. So.
Oh, I also have another question.
Yep.
Is there a way you can like reverse it? Like, I was looking at Desmo, so one of the questions is like you have to actually find the number that you're plugging in.
Ah.
So like, is there a way? Huh?
So on our web work?
Yeah, there's like it's like one of the questions is like like the other questions are like finding the exact value, which like we already like established that, but like there's a question where you have to find like the reverse and like find the value that you're supposed to be plugging in.
Yeah, so I'll bring up, I think I know what you're talking about. I'll bring up web work here and share so everybody can see the exact problem. Do you know what number it is, Gabe?
I think it's 5. Yeah, I figured it out because one of the other questions happen to have the same exact value, so I figured that out. But like, I just want to know like how you should do it.
Okay, so let's go ahead and let me share this here. So like this question right here.
Yeah.
All All right, so given that cosine of alpha is negative root 2 over 2 and alpha is in quadrant 2, find the exact value of the remaining 5 trigonometric functions. Okay. Okay, so let's try this out. Okay, so I'm not going to do all of them, but we'll see some things. So this is the information. We're in quadrant 2, and our value is negative square root of 2 over 2. Okay, so let me. I know we're jumping around over here, but let me go back to this whiteboard. Okay, so here's our info. So cosine of alpha, negative square root of 2 over 2. You want to say hi to everybody? Yeah! Okay. Here. Stop sharing here. Okay. Well, we'll revisit that one, but you can say hi. Can everybody see my daughter Zoe?
Hi.
Hi. You see everybody, right? So can you wave hi? Hi.
Hi.
Hello.
Oh, your daughter's so cute.
Wow. Say hi to everybody. Hi, everybody. She's going to be an internet star by the end of this. Yeah. Are we having a fun time?
Yeah.
Yeah. Do you want to give Daddy 5 minutes to wrap up here, and then I'll go play? We can go play?
Come here. Come on.
Okay.
My crayon.
You want your crayon?
Yeah.
Okay. Can I give you one of these, and you go see Mama? Just for 5 minutes, and I'll come see you? Okay. I'll be right there, all right? All right, so let's wrap this up here. We'll go back to the screen. Yeah, that's my daughter. Her name is Zoe. She's home with us now full time. So we are juggling. We're juggling daycare and working. So we're all trying to make it work. All right, and then the other thing we had here was quadrant 2. Okay. All right, so the way that I would think about this is I would come over here and say, hey, this is quadrant 2, and my coordinate is negative root 2 over 2. Okay, so this is a special value. It doesn't work for this isn't going to work for every number here, but what we know is that this is sort of one of our special numbers. And what I know is when alpha is pi over 4, right, I know that cosine of pi over 4 is equal to the square root of 2 over 2. So pi over 4 is over here. So now I need to think about what is the angle in quadrant 2 that corresponds to this same thing, this same value, cosine of pi over 4. And does anybody know what that angle is?
Is that 3 pi over 4?
Yeah, so this is pi over 4, right? And then if we go all the way here, we can break it up into 3 pieces, right? So this is pi over 4 in blue, and so this is going to be 3 pi over 4. Right, so really what we're looking at is we're looking at cosine of 3 pi over 4 is negative root 2 over 2. And so this is your alpha. All right, so your alpha is 3 pi over 4. And Gabe, does that help you out now? So this is what we're able to do. We're able to figure out what alpha is. And then if we go to the all right, so then if we go to the problem, it's asking us, hey, what are all the different values of this? And so once you know what alpha is, you could then figure out, hey, what is sine of 3 pi over 4? And then what is tangent of 3 pi over 4. So it would be very similar to the problems that we were just doing.
So then you can like simplify the alpha, and then you get 135. Then you can just plug it in.
You could plug it in, or you could
Alright.
do the same process, right? So
Mhm.
like what we did over here, right? So right, we had this that we were doing, remember?
Mhm.
So you could do something like this. If the only thing you're looking for is the answer, the numerical value, yeah, you could plug it into a calculator. So what I'll do for the WebWork problems, I would try to do them without a calculator. And if it comes down to it, if you have to do that, I understand. But see if you can get it, right? So try it out. See if you can get these values without them first, and then
Alright.
then always check them with decimals.
Mhm.
Is the WebWork gonna want them in decimal form, like fully simplified, or is it gonna want us to give them like the square root 3 over 2 or whatever?
So generally, I think for this one it says put them in the exact form.
Okay.
So it depends. Sometimes WebWork is finicky about that. Sometimes it says it's okay, and it will allow you to plug in decimals. But again, for me personally, when I do WebWork stuff, I go to the exact answer just because then I don't have to worry about how many decimal places.
Yeah.
If you are putting in decimals, I would always put more than you think you need. Like I would put 5 or 6 decimal places.
Okay.
But keep in mind, anything on WebWork, if you think it's wrong, you can always email me. I can always go back and change those things and make them correct. Right. So if you think they're correct or you missed a parenthesis somewhere, I don't want you to get penalized for those kind of mistakes. So let me know, and I can go back and fix it. Okay.
Alright.
All right. So while we are on here, I'm going to jump off of this. But it's 11:02, so we're out of time. I just wanted to very briefly, while we are here, we do have the Desmos project that's due in 2 weeks. So what I want you to do is take a picture, right? Take a picture of yourself and upload it to Desmos. So how do we do that? So we saw how to do that with the last project, right?
Mm-hmm.
Is everybody comfortable with that? So let me go ahead and share my desktop here. So can you all see this screen?
Yeah.
All right, so if I want to go and upload this, right, so I could say, here's a picture of baby Zoe, right? So I could upload this image, and then I could use all the different function types that we've seen before to go ahead and try and trace her. Okay, so so if I did, we did a lot of stuff with quadratic functions, right? So I could sort of play around with this and then try to sort of get her face in the right spot, right? So I would want sort of this parabola to be over here, and sort of if I zoom in, one really helpful thing is to think about vertex form, right? So if this point right here, it looks like it's negative 0.3, 0.3, I can use my vertex form to sort of put that point on here. So this is x plus 0.3 and then plus 0.3, right? So that would sort of trace the bottom of her face. And if I want to bend it up and down, right, I can do things like, I can scale this up, or I could scale it down to sort of trace the bottom of her face. So something like this. And then what I'll do is use the same process to try and cut off where it starts and ends. So like if it looks like at -1, it starts to go off. and then maybe over here at point. Okay, so I could do something like this, where I just start with the bottom of her face, you know, and then we can go around and then do different functions to get the whole face. So, but anyways, I'm 5 minutes over here, but try this out, and then at the beginning on Tuesday, so at 9:45, if we want to check in, we can take a few minutes to think about, right? We can think about our Desmo self-portrait. So any type of the functions, right? You can use the trig functions. You can use
Y equals mx plus b.
you can use linear functions. You can use we're going to see exponential functions next week, or on Tuesday, on Thursday as well.
So do you want us to at least have like a face or a head done by the time Tuesday or Thursday's class comes around?
No, so it's 2 weeks, so it won't be due for 2 weeks. You'll have 2 weeks to work on it. But if you put in some time and then sort of see what you're having trouble with, and you can bring those questions, and I'll answer them on Thursday.
Okay.
Okay. Other questions, comments, concerns?
No.
No, not really.
So the trigonometry stuff, that'll be due on Sunday. There's 10 questions up there, so we can field some questions on that. And then we'll move on to exponential functions and exponential growth, which you've probably been hearing a lot about in the news. So yeah, on Thursday we'll start that. We'll see sort of what we can figure out through exponential growth.
All right.
All right, so we're out of time, but I'll see you all on Thursday.
Okay.
All right. Have a good day.
You
Have a
too.
great day,
Have a good
everybody.
day. Everybody be healthy.
Bye.
Be healthy, be safe. Bye.